So for the connection, we'll start from the positive of the battery, we'll go to the meter bridge. Now from the meter bridge, your one gap will be connected to the shunt resistance. From the middle of the meter bridge, we will go to the galvanometer. From the galvanometer, we will go to the jockey. Now, the other gap of the meter bridge is connected to a unknown resistance. We have to find the resistance of this unknown. Next, from the other end of the meter bridge, we will go to the key. From the key, we will go to the negative of the battery. Now, while finding the value of the unknown resistance, make sure while finding the null point at the meter bridge, you should always find the null point at the galvanometer, always near the center of this meter bridge. Let us say from 45 to 55. The null point of the galvanometer should always lie between these points. Fine? Now, to perform our experiment, first we will remove 1 ohms from our unknown resistance box. Now we'll try to find the null point on the meter bridge. Now, as you can see on the galvanometer, the null point for this 1 ohms is coming somewhere around 41.3. So we have to remove some higher resistance from the resistance box. So let us remove 1.5 ohms. So as I have removed 1 ohms from here and 0.5, so in total I have removed 1.5 ohms. Let's find out the null point on the galvanometer. Now, as you can see, the galvanometer is showing the null point at a length of 45 centimeter on the meter bridge. Now, it is still near 45. We will try to get at the center of the meter bridge, which is 50 centimeter. So what we will do is, we will remove some more resistance. Let us say we remove 1.6 ohms. So the deflection is coming somewhere around 46.5. Okay. So let us remove some more resistance in our case. Let us remove 1.8 ohms. Fine. Now on the 1.8 ohms, as you can see, my deflection is coming at 0. So for 1.8 ohms, the galvanometer is showing the null point at this length, which is 49 centimeter of the meter bridge, as you can see in the galvanometer. Now, after taking your first reading, in similar manner, you will increase your resistance by 0.1 ohms. So earlier, I took 1.8 ohms. Now for the next reading, I will take 1.9 ohms. Now for this 1.9 ohms, I will find the null point on the meter bridge. In the similar manner, you will take 3 sets of readings. Now we'll connect our second unknown resistance. Now we'll find out the resistance value of the second one. Fine. Now to find out the second one, we will repeat the same procedures which we have followed for the first one. So we will remove some unknown resistance from our resistance box. So let us suppose we remove 2 ohms from our resistance box. Fine. So let us remove 2 ohms and check where is the null point. Now as you can see, when I have removed 2 ohms from the resistance or our shunt resistance, the null point is coming somewhere at length of 50.8 centimeter, and the galvanometer is showing 0 deflection at this point. Fine. Now, for the next set of reading, we will increase our resistance by 0.1 ohms. So earlier it was 2 ohms, now we will remove 0.1. Therefore, I have removed 2 plus 0.1, 2.1. Now for this 2.1 also, we'll find the null point and show the 0 deflection on the galvanometer. For the next set of reading, I will again increase by 1 ohms. In this manner, you will take 3 sets of readings. Fine. Now, theoretically, we have calculated the resistance of the total resistance of these two resistance in parallel combination came around to be 0.9 ohms. Fine. So we will remove our resistance from the resistance box such that we can find the balance point on the meter scale and null point on the galvanometer. Now, since our parallel combination resistance came around to be 0.9, so we will take our resistance, or let us say we will take the 3 sets of reading to be 0.6, 0.7, 0.8 and 0.9. Now note, since we got 0.9 ohms as our parallel resistance, therefore we cannot go beyond 0.9. Hence we will start from 0.6 ohm. So there is 0.5, let us remove 0.1 ohm and let us find the null point on the galvanometer. Now we'll find the balancing length on this meter scale. Now, as you can see, at a length of 47.3 on this meter bridge, I'm getting a null point on the galvanometer. It is showing us 0 deflection at a length of 47.3. Therefore, for the resistance of 0.6 ohms, we are getting a balancing length of 47.3. Fine. Now, for the next set of readings, we will increase our resistance by 0.1 ohms. So we took 0.6 ohms. Now we'll take 0.7 ohms and again find the null point. Fine. In the similar manner, you will take 3 sets of reading.